All right, so this is the beginning of Chapter 9, Section 1, and in this chapter we are talking about conic sections. And what that really is taking a look at an ellipse and a hyperbola, a circle, and a parabola. Now, we're going to draw a picture here really quickly, and conic sections are if we have a double cone. And what we've taken is a section of this double cone. So if I take a circle, that would be cutting horizontally through the conic section. If I look at maybe a parabola, that would be cutting through part of our conic section horizontally. If I look at a hyperbola, that's cutting vertically where we're getting a piece up here and then a piece down here. And then, let's see, parabola, ellipse would be cutting slanted through this double cone. So maybe cutting slanted like this. Okay. So we're going to be looking at each of these conic sections, and let's first take a look at the ellipse. We can either have a horizontal ellipse where it's wider, or a vertical ellipse where it's taller. And these are the formulas for a horizontal and vertical ellipse where the center is at the origin. Now with ellipses we have this term called a focus. These are our foci right here. And then if we have a vertical ellipse, they're on that axis right here. This is called the major axis. Whichever one is longer is the major axis. The shorter one is the minor axis. Okay. And then the values here below x and y tell us what our points here are. These are our vertices and co-vertices. These are our vertices and then co-vertices. A always corresponds to the vertex and B always corresponds to the co-vertex. Now we've covered all of that information. Let's go ahead and practice graphing one of these. So we have this equation right here, and this does not look like the formulas we just saw. We want to divide by 400 everywhere. And now we'll have that equals 1 on the end, and 25 over 400 reduces to x squared over 16 plus y squared over 25. Now, depending on which one of these is bigger, that will be our A value, and that will tell us if this is vertical or horizontal. This is our A value, and this is B squared. And so this means that this is a vertical ellipse. Okay. So this is a vertical ellipse. Now let's go ahead and graph it. Its center is at the origin, and we're going out vertically. Our A value is 5 and our B value is 4. So we're going to go out vertically 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 4 horizontally. These are our vertices and our co-vertices, and this is our ellipse. Now the only thing left to do is to find our foci, and that's using a formula that we have right here. Okay, this is the formula for the focus, c squared, and the c value is always on the major axis. So for this example, it's going to be on the vertical axis. So our c squared is equal to a squared minus b squared, so 25 minus 16 is 9. So C equals 3. So going out 3 on that major axis gives us our foci. And we need to state the focus here. So our foci are at 0, 3 and 0, negative 3. And that's the end of that example. Let's go ahead and flip the page onto the next example. So our next example says find the standard form of the equation of an ellipse where our foci is at negative 1, 0, and 1, 0, and vertices at negative 2, 0, and 2, 0. So even though we don't have to graph, we're going to just sketch where these points are. -1 is our focus, and then -2 is our vertex. Okay. So this can allow us to find out what our A and C values are. If our focus and our vertices are horizontal, then that means this is a horizontal ellipse. Okay. So then my A value from the center out to the vertex is 2, and my C value from the center to the focus is 1. So if C equals 1, A equals 2, we can solve for B, and we can plug it into the horizontal formula, which is x squared over A squared plus y squared over B squared equals 1. So C squared, which is 1, equals A squared, which is 4, minus B squared. And we really only need B squared. So B squared equals 3. And that's what I can plug in right here. A squared is 4, so my answer is x squared over 4 plus y squared over 3 equals 1. Okay. And now looking down at the bottom of this page, we can also talk about what if my center is not at the origin, what if it's at HK? So this follows the same pattern of HK that we've seen in every type of graphing that we've seen so far. So this should be pretty familiar at this point. If our HK is, let's say, 5 and 4, then this would be x minus 5 and y minus 4. And then the same rules apply about A squared is the bigger term, B squared is the smaller term, and then that determines whether it's horizontal or vertical. Okay. So let's go ahead and take a look at one more example here. I'll zoom in a tiny bit here. So the first thing we want to do is determine is this horizontal or vertical. And the larger number is under y, so that means this is a vertical hyperbola, or a vertical ellipse, excuse me. And we want to go ahead and write what our center is. And this is h and k, so that would be 1 and -2. So let's go ahead and start by graphing that. So our center is at 1, -2. That's our center. And we know that this is a vertical ellipse. Well, my A value is 3, and my B value is 2. I'll zoom in on that a little bit. And so what that means is that I can know that I'm going to go, since this is vertical, up 3, 1, 2, 3, and down 1, 2, 3, out to the sides 2. This is the shape of my ellipse. And now I just need to find my foci. So my focus, we know, is c squared equals a squared minus b squared. So c squared equals 9 minus 4. C equals the square root of 5, which is about, let's see, 2.1. So I'm going to go out 2.1, and that'll give me my focus, and about 2.1, and that'll give me my focus. So my foci are at, let's see, 1, and going up from -2, 2.1 would be 1 and 0.1. And then our other point going down 2.1 from 2 would be, let's see, -4.1. And those are our foci. And that's going to be the end of section 1, chapter 9.